for easy and quick. It enables us for easy and quick understanding of data. And normally when we have number of data sets, then easy comparison can be made using graph. If we have 2 or 3 data sets, maybe from different institutions or maybe from different hospitals, then easily we can compare those data sets using graph. Instead of numbers, comparisons is easier with the case of graph. So these are some of the uses. I think we all are familiar. Now, the next slide tells you, okay, this slide tells us the classification of graphs according to the types of data. Now, I am not very sure if types of variable or data has been taught to you all. Has it been taught to you all, the types of data? Not yet, okay? So broadly, I discussed, we can classify data into 2 broad sections. You all must have heard about these 2 terms, qualitative data and quantitative data. Now, can any one of you sitting here very briefly in one line, just tell me what do you understand by qualitative data and quantitative data? So we begin with qualitative. Any one of you sitting here can give me an idea, or maybe anyone who is joined online can write in the chat box. If you understand what is qualitative data and what is quantitative data.
Data which is captured in numbers is quantitative.
Yes.
And non-number data is.
Okay, perfect. So we got a good reply and a very precise reply which said anything which is in the form of numbers is a quantitative data, and the data which we cannot quantify or we cannot put in numbers is a qualitative. Now, I will be dominantly using English language because we have participants from South also, but beech mein jahan hoga, wahan we'll also be using mixed language. Okay. Now, to elaborate the definition which sir said, I will like to mention a few things. Any variable, now there are 2 things in statistics which you all must be aware and must have heard of, variable and constant. Any quantity which varies from an individual to individual is called variable, and a quantity which remains constant is called, or which does not change is a constant, right? Now, anything which is varying from individual to individual is a variable. When there is variation, there is a statistics, and when there is no variation, there is no statistics. So variables can further be classified into 2 sections, quantitative and qualitative. Now, quantitative means a variable which is capable of being measured or counted. There are 2 different words which I am using. A variable which is capable of being measured and counted is called a quantitative variable. Now, can any one of you again sitting here give me an example of what types of variables could be measured and what types of variables could be counted? Now, these are 2 different words having completely different meanings. Measurement and count, both of them come under quantitative variable. An example of a variable that can be measured. Very good. Height, weight, all these variables, volume, pressure, all these can be measured. Now, when we talk about count, in an example of a variable that can be counted, number of students in this classroom, number of chairs in this classroom, number of tables in a class, and so on. These are all count. Now, another difference between variables which can be measured and counted is, when we talk about variables that are capable of being measured, then we talk about those variables where between 2 points, there can be infinite possibilities or infinite numbers. It depends on how precise your measuring instrument is. For example, height, it can go up to 10 decimal places, it can go up to 20 decimal places, and so on, depending on how precise is your measuring instrument. So we have infinite possibilities. That is also a quantitative. While when we talk about a count variable, then we say that there are distinct points, like chairs cannot be 2.5 in a classroom. Number of children cannot be 3.5 in a classroom, right? All these come under a quantitative variable category. When we talk about qualitative, then those variables which are capable of being categorized are called qualitative variables. Now that categorization has a property. Now that property is the categories have to be mutually exclusive and exhaustive. Now, these two terms are again highly used in statistics. So very briefly, I tell you what does this mean. The categories need to be mutually exclusive and exhaustive. Now, I'll give you an example of a categorical variable with these fulfilling these criteria. Now, for example, I say gender, right? Now, any individual can have 3 types of gender, for example, male, female, and another third one, right? Mutually exclusive means an individual will fall into either of the 3 categories only. A person cannot be both. Now, this we all know, an individual cannot be male as well as female, right? So, either of the categories. This is called mutually exclusive. And exhaustive means within these 3 categories only an individual is supposed to fall. So you all are also going to be researchers in future. You'll be designing various questionnaires. During designing of the questionnaires and framing the questionnaires, this also should be kept in your mind when you are creating a variable that is supposedly collecting data on a categorical scale. Then it should be kept in mind that categories are very clear and they are mutually exclusive as well as exhaustive. It should be covering all the possibilities, which means other than these 3 categories, there is not any possibility, right? So we can broadly classify variables into 2 parts, quantitative and qualitative or categorical. Normally, these are the types of graphs that are commonly used. There are other graphs also, but when we talk about preliminary statistics or the basics of statistics, then we focus on these types of graphs only. So to begin with, if we start with categorical data and the graphs for categorical, then or qualitative, then we can make line graph, bar graph, or pie diagram. Now, what all these graphs are all about, as we move into the slides later on, I will be discussing in detail. Likewise, moving into quantitative data, we can plot histograms, we can plot box plot, frequency curve, frequency polygon. Then there's another stem and leaf plot. So as we go ahead during this lecture, I will be discussing with you all what these all graphs are all about. So first we start with the first type of categorical data graph, that is a line graph. Now, as you can see in this image on the right side of the screen, this is a simple line diagram where this kind of data, which you can see in the table below, we have different time points and we have number of people. Now, if you want to plot it on a simple graph, so on the x-axis, we have time, and on the ordinates or the y-axis, we have, you all know x-axis is called abscissa and y-axis is called ordinates. So on the ordinate, we have the number of people or the frequency, and on the x-axis, we have time point. So if we just want to plot using an XY plot, you can put these points and you can draw a straight line. That simply becomes a line graph. And it is dominantly used for data which is categorical or qualitative in nature, right? Any doubts up till here? Okay. So the next one again, which is very, very frequently used, is called bar graph. Again, which is used for a data that is qualitative in nature, which means distinct. You have categories which are distinct. So an example which is shown here is for different months, suppose we want to find out how many buses were manufactured. So again, on the x-axis, we have different months, and on the y-axis, we have number of buses which were manufactured. So these are vertical bars which are made, and again, they have to be distinct. There have to be space because these are discrete categories. So this is a simple bar diagram. A further modification. Now, before we move to further modification of bar diagram, I would like to very quickly tell you all, however, in the hands-on section, we will be making all these bar diagrams. I'll try to possibly show you all the graphs that could be made in SPSS, but these are some of the uses of bar diagrams. So first, as I already said, whenever we have to plot a frequency distribution, just as we saw in the previous slide, when you have number of buses and for different months, you want to see what is the frequency distribution. That's the first one. Going to the second, when we want to see the fraction. Now, you all know what's a fraction? Proportion of total observations having that particular category. So out of the total, how much proportion that particular observation is having. So that can also be drawn using a bar diagram. Then the third one is cumulative frequencies. You all must have heard of less than cumulative frequency curve, more than cumulative. So suppose instead of simple frequencies, we have cumulative frequencies. Those can also be made, can also be plotted using these bar diagrams. And the last and the most interesting is the mean. Now, this should be a question, or you people must have, this question should come to your mind कि अब तक तो हमने ऐसा पढ़ा है that mean should only be used for what kind of data? I mean, mean should only be calculated for what type of data? Quantitative data, right? Continuous. But यहाँ पर तो मैम qualitative में mean कह रही है. Now, there is a difference on how bar diagram can be categories of gender. And I want to see the average age for each of the categories of gender. So again, age becomes that variable for which I am calculating the mean. So I am taking average age, but that average age is being calculated or being represented rather for different categories of gender. So this is how we use a quantitative as well as a qualitative data in a bar graph. So in the hands-on, I will show that to you also, how to make it in SPSS, right? So some of the uses of bar. This is a type of bar diagram that can also be made in SPSS, which is called a segmented or a stacked bar diagram. Now, I can see many of you nodding your head, which means you people must have either made it or seen it somewhere in your research papers. Now, the use of this segmented or stacked bar diagram is that suppose we take an overall, now just look at this graph. Can any one of you simply interpret this graph for me? I will do it for you later, but just to begin with, can any one of you interpret this? There are 4 different categories. So these 3 are categories of a, suppose train. In a train, we have first class, second class, third class, and crew class. And then that train met with an accident, unfortunately. So some of them died and some of them survived. This is what is demonstrated using this bar. Now, it's a categorical data number 1. So whenever you see a categorical data, keep this in your mind. You have to make a bar. Now, this is a segmented or a stacked bar because we are using 2 categorical variables at a time. What are the 2 categorical variables? Can any one of you tell me? Again, types of people who died, I mean, died and survival, that's one. And the second, classes of, okay, classes in a train. Now, just by looking at this, can any one of you interpret this? The first, ऐसे सारे बोलेंगे तो बहुत मुश्किल होगा. If any one of you can raise your hands and say, हद से हद क्या होगा, हम गलती तो बोलेंगे. मैंने भी इस कमरे में बैठ के बहुत सारा गलत बोला है. Very good. Perfect. Sit down. Thank you. So just as she said, we can see there is a decline in the survival, right? That's the first observation. If otherwise, I would have simply plotted just people who died or just people who survived, it would have been difficult for me to see the trend. So whenever we have to compare the trend across different categories or see the trend, in that case, these types of graphs do give you an ease. So, and one of the good things about this stacked bar is you should always scale it to 100%. Now, those of you who are noting this down, please note this down. When we do this in SPSS, I will show you on how to scale these graphs to 100%. Scaling means all of them have an equal level. In that, we will be comparing. So she can now easily say that 40-60% of them survived in the first, then it declined, and so on. So whenever you have scaled it, you can easily compare. So using two categorical variables, we can either make this kind of segmented or a stacked bar, and we can also make this kind of clustered bar. Now, both the types of graphs are almost same, and both of them use two categorical variables. So two variables you should have, both of them qualitative in nature, and both the variables need to have categories. Now, it's not necessary that they should have only two categories or they should have only three categories. As many number of categories, and both of them work on both two categorical variables. The only thing with these types of graphs is that the difference between rather stacked and clustered is, in stacked, you have representation one over the above, and in clustered, you have representation side by side. For some specific cases, or to rather interpret, just I gave you this example of died and survival. In that case, it is anyways better to go for a stacked bar because that will give you a better representation. But in this case, or this example which I'm showing you right now, it's better to go for a clustered bar because then you have a side-by-side representation. Now, this question might come into your mind that which is better. Both of them are equally important and both of them have equal relevance. It's up to you on how you want to interpret. So you can either go for a stacked bar or you can go for a clustered, depending on your own objective. Both of them use same types of categorical variables, right? Is this clear till here? Are you people understanding, all of you? The next and the most interesting graph, which is used for a bar, which is used for a categorical data, is a pie diagram. Now, all of you have seen pie diagram. हम अपनी रियल लाइफ में भी पाई देखते हैं रोज. कोई बता सकता है कहाँ पे? It's not a difficult question and it has nothing to do with the statistics. Yes. How many of you like eating pizza? So that's a very clear-cut example of a pie. It's a pizza or a roti. That's all a pie. Okay? You make its different categories and that's a representation of a categorical variable. Now you can either show it in the form of a frequency or you can show it in the form of a percentage distribution. Okay? So I'll show you how to make this pie also on SPSS. So as you can see, it's in a form of a circle and different areas represent different parts. And then we have percentage distribution. So first, second, third, and failure. Easily we can see more than 50% of the students have secured second division in the data. Data that we are using, more than 50% of the students have scored or have got second division. This is what is the use of pie diagram. Now we come to histogram. That is for quantitative data. Okay. Quantitative means continuous data or data which is measured in a numeric scale. This is just like bar diagram, but the only difference between a bar and a histogram is that bar has to be distinct because it is for a categorical variable and histogram is for a continuous variable. So it is all the bars are actually combined. It's a one full histogram. This is an example where we have the frequencies and easily we can see it. This can also be constructed for data which has equal intervals and which also has unequal intervals. So I'll show you on how to do that. One of the advantages of histogram is that you can, please connect my charger. One of the advantages of histogram is that you can calculate mode and you can also calculate median using histogram. Can any one of you tell me what, I'm not asking how to do it in SPSS. I'm asking what do you understand by median and mode? What is median first of all? Not the students of statistics. Yes. You can sit and answer, that's fine. Yes. So median is, you want to, अच्छा, मुझे लगा कुछ और थोड़ा better answer आपके पास, मुझे fine. So median is an observation which exactly divides your data into two equal parts. It is just a half of your data set, and mode is that observation which very frequently occurs. Now, one of the advantages of using or making a bar diagram or a histogram is that using these graphs, we can also calculate these statistical measures. So both of them are histogram, and we can see using this histogram, we can easily identify the mode. Now, mode is, as she said, that particular value which has the highest frequency, which is occurring largest number of times. So you have that bar. When you join those two ends of the bar, the point at which these lines intersect, that will be termed as mode. So this is how graphically you can also find out or calculate mode. Now, tomorrow, most likely, you will be having a lecture on descriptive statistics, right? When these descriptive statistics measures will be taught to you, remember one thing, there are two types of averages or two types of measures of average which we study. One are called mathematical average and the others are called positional average. Now, the good part about these positional averages is all these positional averages can be calculated using graphs. So some of the positional averages which I would like to tell you the names of are median is a positional average. नाम से ही समझ में आता है exactly at the half. So 50% of the observations we can calculate it using histogram. कैसे calculate होता है? Histogram से कर सकते हैं या otherwise भी you all know about cumulative frequency curve. Suppose we draw a less than cumulative frequency curve and we draw a more than cumulative frequency curve. The point at which these graphs or the curves intersect gives you the median. So that is one way how which you can calculate median graphically. Mode, how you can calculate graphically, is shown here. Another measure which can also be calculated graphically is called quartiles. Now, what are quartiles? They divide your data into 4 equal halves. What are percentiles? They divide your data into 100 equal. So all these measures, you draw the cumulative frequency curve, and suppose you want to see Q1. So from the y-axis, just see where is the, so Q1 means 25% of the data. So at 25, you draw a straight line. Whenever that lines intersect, there are drops on the x-axis, that becomes your first quartile. Similarly, we can find out median. Similarly, we can find out third quartile, all the percentiles. So then these are called positional averages. So we can compute them mathematically and we can also compute them using the graph. Okay? After histogram, there is this one more graph which is called frequency polygon. Now this is also just like any other graph which you people make. The difference between a histogram and a frequency polygon is, in the histogram we have class intervals and we are marking it on the class intervals. Here, instead of class intervals, we are using the midpoints of the class interval, and then we are entering the frequency, and that is now joined using a straight line. If that straight line is converted or you change that straight line into in the form of a curve, then that frequency polygon becomes a curve. It's called a frequency curve. When you join those points by a freehand curve. One thing here which is very important and which I would like to discuss with you all, that is when to use a frequency curve and when to use a frequency polygon. If you can see this circular box at the end, it shows when the number of class intervals are very large, which means when the categories that you have in your data, when their number is very large and the categories are smaller in size, I mean the width of the class interval is not much, But if the number of class intervals is very large, in that case, it is better to use a frequency curve rather than using a frequency polygon. Because likewise, अगर आपके intervals ज़्यादा होंगे, तो वो वैसे भी it will be a free, it will, I mean, when you join the points, it will not be a proper straight line. So then it becomes a frequency curve. So when you have a data set which has many number of intervals and the size of the interval is small, in that case, it's better to use a frequency curve rather than a frequency polygon. And both of them can be used interchangeably depending on your own convenience. Okay. Now, the most interesting part of data representation using a quantitative data is a box and whiskers plot. Now, what is whiskers? हाँ, सबसे पहला, the moment I ask what is whiskers, generally the first answer which I get is cat. है ना? I don't get the answer मूछे, but I get the answer cat. So box and whiskers plot is exactly the same. You have a box and then you have two straight lines which are the whiskers of that plot. Now, since you people have not been taught descriptive statistics, so very briefly, I will explain you some parts of descriptive statistics so that it is easy for you to understand box and whiskers plot. First of all, why is this plot made and what is its use? Normal distribution के बारे में कितनों ने सुना है? बहुत कम. जैसे जब हम when we start studying, what's the first thing that is being taught to us? Alphabet, ABCD. होता है या भूल गए ABCD? We use it in our daily lives every day, so we remember the alphabet. Normal distribution, I would rather say, is the alphabet of statistics. Whenever we talk about any testing, when we talk about distribution fitting, when we talk about methods of estimation, normal distribution or NPC, which you people normally call normal probability curve, that is the first thing which is being taught. So what we assume is that if a distribution or a data is said to follow a normal distribution, it means that mean, median, mode all will lie exactly at the same point, which is at the center of the distribution. And if you draw a line at the center, a vertical line at the center, then points which lie on the left side, exactly same number of points or same number of observations would lie on the right side as well, which means the left and the right side of the centers are mirror reflections of each other. So it's a symmetrical form of distribution. Now, why is it important in statistics? If I explain it to you in very layman terms, then I would like to state here that any testing which we apply, so in this course of the workshop, you will also be taught about various parametric and non-parametric tests as well. All these tests, some of the procedures are applied to a data which is assumed to follow normal distribution. If it is not following, if the parent population from which the sample is drawn, if it is not following a normal distribution, then we are, or rather we should not apply these tests and should go for corresponding non-parametric tests. Right? So that is why checking for normality of data is one of the most important things when we perform exploratory data analysis. Tomorrow's lecture is going to be extremely important in the sense that the first thing that is done with the data is called its descriptive analysis or exploratory data analysis. Now, I'll tell you a very small example which also states on why EDA is important. आप सब कभी ना कभी डॉक्टर के पास गए होंगे. I mean, I'm not saying that you should go. कभी ना कभी अपने लिए या फिर किसी relative, mother, father, grandparents को लेके you people must have visited a doctor. Nowadays, specifically nowadays, what's the first thing that a doctor does when you go and visit the doctor? Test. But अगर इंस्टेंटली आपको बुखार आया है, he might give you a paracetamol, but he will not prescribe any antibiotic or any medicine, because वो बुखार मलेरिया भी हो सकता है, वो बुखार जॉन्डिस या किसी और वजह से भी हो सकता है, या वो आजकल जो कोविड है उसकी वजह से भी बुखार हो सकता है. दैट फीवर कैन बी ड्यू टू एनीथिंग. तो वो आपके ढेर सारे टेस्ट लिखेगा, डायग्नोस्टिक टेस्ट. नाउ EDA और एक्सप्लोरेटरी डेटा एनालिसिस is the diagnosis of your data. So we all sitting here, जो हमारे PhD के बच्चे हैं और जो MSc स्टैटिस्टिक्स हैं, हम सब अभी या फ्यूचर डेटा डॉक्टर्स हैं. So the first thing that we do whenever a data comes to us is diagnostic testing of that data, which is in other words called exploratory data analysis or EDA, which means testing for the mean, median, mode, all the measures of descriptive statistics, testing for normality, testing for measures of dispersion, skewness, kurtosis. ये सारी चीज हम आइडेंटिफाई. फिर एक दो वर्ड्स हम और अभी नए यूज कर रहे हैं आपके साथ, which is called. So since we have lot of time अभी, I have been given 1.5 hours to tell you the theory of graph. तो हमारे पास बात करने के लिए अभी बहुत सारा टाइम है. So I'll explain you these two important terms जो इस ग्राफ में भी दिख रहे होंगे आपको बॉक्स प्लॉट में, जिनको बोला जाता है एक्सट्रीम वैल्यूज एंड आउटलायर्स. Now can any one of you sitting, how many of you have actually heard about these terms, extreme values and outliers? ये सब कुछ मैं अभी बताती हूँ what this actually means. ये सब कुछ आता है in diagnostic testing or EDA of your data. So box plot is also very important in diagnosis of your data. जो वेरिएबल आपको दिया गया उसका डिस्ट्रीब्यूशन किस तरीके का है, to be able to identify that, so that we are in a shape, we are in a position to decide whether we have to go for parametric testing or non-parametric testing. मतलब किस सेक्शन में वो डेटा फॉल करता है. Now very recently we were working on a data, I along with my students, we were working on some data set, education department का था. Most of the variables were non-normally distributed, one or two variables were normally distributed. आप सब भी कभी ना कभी डेटा पे या तो काम कर रहे हैं या you will be working on the data set, and trust me, you will come across those data sets which are non-normally distributed. So any data set, always remember, any data set which is non-normal is not wrong. It's absolutely fine. It's the distribution, and if it is not normal, you should respect that and you should accordingly perform those statistical tests which should be performed when your data is not normal. तो कई बार मैं ये apprehensions आप सबके mind, those of you who have joined us online as well as offline, I would like to make it clear to all of you, it is absolutely fine if your data is not normal. I have been taught by my professors, and what I have been told is there is no data as of now which is absolutely normally distributed. So perfect normal, जैसे कहते हैं ना, there is no human being in this world also which is perfect. There is only one being which is perfect, and that is the Almighty God. So similar case is with the normal distributed data. You will not find a data set that is exactly normally distributed. So if your data is coming to be non-normal, it's absolutely fine. मेरे पास लोग आते हैं जो बोलते हैं मैम हमें लग रहा है कि there is some problem in our ways of data collection, तभी वो non-normal. क्या हम उसे normal कर सकते हैं? There is no problem in that. It's the basic nature of the data, and it should be normal or non-normal, whatever it is coming. So coming back to this, all those things can be identified using this box plot, which is an integral part of your diagnostic testing or EDA. यानी अगर हम बोलें तो इसको हम CBC कह सकते हैं. Complete blood count होता है. So this is actually your CBC. If I like to relate this with medical sciences because that is dominantly my field of research also. So this can very easily be said as a complete blood count of your data, which tells you whether it is normally distributed or not. Coming to the interpretation of this, what all these points are. Do we have a pointer by any chance? नहीं है तो कोई बात नहीं. This line at the there is a blue box which you can see, all of you, in the screen also. Now this blue box, which is here, the mouse is not visible over there. This blue box, the center line of this blue box actually tells you the median, the middle, exactly the middle point of your data where your 50% observations lie. They are below this and the 50% are above this. So that point, the center is your median. Then if we see the line at the top of this box, that is your third quartile or Q3. And if we see the line at the bottom, that is your first quartile or Q1. So ये डब्बा तो clear हो गया, Q1, Q2 and Q3. Now Q2 is your median. So we have Q1, that's the first quartile. Then you have Q2, that's the second quartile. And you have Q3, which is the third quartile. उसके बाद these whiskers, they are 1.5 times of the interquartile range. Now what is the interquartile range? इस graph में that interquartile range is demonstrated by H. So interquartile range means Q3 minus Q1. So the line, so these two are actually the whiskers. ये जो दो blue lines आप देख रहे हैं. The line at the bottom and the line at the top is the 1.5 times of IQR. So नीचे वाली line क्या हुई? Q1 minus 1.5 of IQR. And the line at the top is Q3 plus 1.5 IQR. If you people are noting, I'll repeat it once again. The line at the bottom is Q1. You can make this box plot and then you can also write. However, I think these slides will be shared, most likely will be shared with all the participants. But anyways, लिखने से ज़्यादा समझ में आता है, at least मुझे. So line at the bottom is Q1 minus 1.5 times of the interquartile range, and line at the top is Q3 plus 1.5 times of interquartile range. An ideal box plot, and by an ideal box plot, I mean a box plot for a normally distributed data is one where all these points are equidistant. Now, equidistant means जितना ये whiskers होंगे, उतना ही ऊपर नीचे दोनों के whiskers उसी size के होंगे, दोनों boxes उसी size के होंगे. So all these four sections are equidistant. If in case they are equidistant, then your distribution or your data is said to be normally distributed or said to follow a normal distribution. So that's your ideal box plot. Now, one thing which I would like to also state here, this is called Tukey's box and whiskers plot. Now, Tukey was again one of these statisticians who gave many concepts, including those concepts for design of experiments, distribution curves, etc. Now, why is it called Tukey box and plot? Because it was made assuming normal distribution. So that's what I'm saying. Ideally, if all the points are at equal distance, we say that it is a normally distributed curve. तो अगर वो equidistant नहीं है, which means दो ही possibility हो सकती हैं. This line at the top may be a longer line. So this means your data is positively skewed. Now, what is skewed? Skewed means departure from symmetry. So if line at the top is a longer line, then it means you have like most of your observations are either more than your center or they are likely towards the right, which means you have large number of higher observations or you have some observation which is very high. That is why you have a longer tail towards right या फिर ऊपर वाली line अगर longer है. Similarly, if the line at the bottom is longer, then we say it's a less skewed or a negatively skewed data. And again, it is not normally distributed. So an ideal normal curve, all these points are equidistant. Now coming to what is outlier and what is extreme observation. If you can see in this figure, outliers are demonstrated by O and extreme observations are demonstrated by star. So this is exactly how they will be represented when we make it in SPSS. when we plot this box plot in SPSS, this is exactly how extreme observations and outliers will be represented. Now, what are outliers and what are extreme observations? Suppose I give you an example and I say, I record the height of all the students who are sitting in this workshop today. Normally, the height is going to vary somewhere from 4'10" to say 5'6", 5'7", 5'8" maybe. That's the average height of the Indian population. So it's normally going to vary from 4'6" to say 4'8", से लेके 5'8", 5'10" तक, we suppose. Now there'll be some students in the class, 1 or 2, which have an average height of, which have height of say 6.1 inches, 6.2 inch, ऐसा भी कोई हो सकता है, 6.3 inch, 6.4 inch तक भी हो सकता है. Those of you will be outliers present in the data. ठीक है, या जो बहुत छोटे हैं 4.5 feet या 4.6, which means outliers are slightly departed from your most of the observations of your data. So you have a measure of central tendency, which is the center point, and where you are assuming most of your observations will come near to that point. So an outlier is something which is slightly deviant from your most of the observations. अब कोई ऐसा भी हो सकता है यहाँ पे जिसकी हाइट 6-10 हो. That becomes an extreme observation. So outliers are a necessary part of your data and they should be retained in your data. मैं आपको एक और एग्जांपल देती हूँ of outlier and extreme observations. एज हम सब कलेक्ट करते हैं अपने डेटा सेट में. Now suppose if we follow the conventional method of data collection और हमने क्वेश्चनर भरवाए और फिर हमने 2-4 बच्चों को 2-3 स्टूडेंट्स we've taken और उनको हमने ले लिया इन स्टडी और उनको ले करके हम उनसे डेटा कलेक्शन, डेटा एंट्री करवा रहे हैं. ठीक है, अब वो नींद में है, वो सो रहा है, वो बात कर रहा है, तो उसने सबकी एज तो ठीक ठाक लिखी 20, 30, 40, 40, 50, 80 एंड सडनली किसी की 20 एज को 200 लिख दिया. ऐसा होता है. These are human errors and we all are human beings. तो डेटा एंट्री के दौरान you did that mistake, तो वो एक एज आपकी ऐसी हो गई which is say 200 or 250 or something which is completely deviating from rest of the observations. Now when you plot this kind of a box plot, then those extreme observations are called, those observations 200 के जैसी, they are called extreme observations. So whenever you, so the advantage of making this box plot is it can easily identify what observations are extreme and what are outliers. The moment you come across these observations, what you need to do is go to that case. Yesterday, Dr. Akash Asthana was taking the class and he told you that cases are the rows and variables are the observations. That is the nomenclature which we normally follow in SPSS. So variables will be your name of the variables, the columns, and rows are your cases. Okay? Whenever you see any particular observation that has an age of 200, immediately go to that case, check. Suppose if it's a data entry error, rectify it. So outliers need to be rectified, rechecked, and if possible, removed from the data. But on the other hand, extreme observations. Extreme observations need to be rechecked, rectified, and if possible, removed from your data. But outliers, you can check for the outliers. You can go through the data and see whether your outliers are valid or not. And then they should be retained in your data because they maintain the basic nature of your data. So outlier present hone chahiye. There are a lot of work that is now being done just to study the outliers. So outliers, they should be present in your data, but extreme observations have to be investigated and if possible removed from your data. अब इसमें कैसे बने हुए हैं? So 1.5 interquartile range तक तो we already studied. Now outliers lie between 1.5 interquartile range and 3 interquartile range. And those observations which are beyond 3 IQR, ऊपर भी और नीचे भी, those are called extreme observations. So is this box and whiskers plot very clear to all of you? So इसमें से कुछ WBC है, कुछ RBC है और कुछ इसमें से क्या है? हीमोग्लोबिन तो मैं भूल ही गई, हाँ ये बीच वाला डब्बा एक्चुअली हीमोग्लोबिन है, ठीक है, डॉक्टर्स माइट नॉट किल अस ना, ठीक है. This is again the interpretation which I already said. If the lines are, so if the box is closer to the bottom whisker, then we say that it is positively skewed, which means you have a longer tail to the right. Similarly, if the box is closer to the top whisker, then in general data is negatively skewed. Both of the wealth of information contained in a box plot is an extremely powerful tool for describing and distribution, and it is also used for comparing distribution. So I will show you both the ways, for one single distribution also, and for different types of distribution, how can we make a box and whisker plot. Again, this is one of the important graphs. However, this was not there in the table that I said, but this is again a graph which many of you must have heard of. This is called a scatter plot, जो सबसे ऊपर बना हुआ है, and the one that is at the bottom is called a scatter matrix. Now, what is the difference between a scatter plot and a scatter matrix? Anyone? Matrix generally is for more than 2 dimensions of your data. So likewise, a scatter plot is made when you have a bivariate data. That is, scatter plot is actually correlation. सुना है ना सबने, दो वेरिएबल्स के बीच में रिलेशनशिप, ठीक है. कोरिलेशन को हम लोग हिंदी में क्या बोलते हैं? सहसंबंध गुणांक. I sometimes find Hindi language to be very, very good because it's more expressive. अब कोरिलेशन किसी को समझाओ और आप सहसंबंध गुणांक बोलो, तो वो सहसंबंध गुणांक से अपने आप समझ गया what is correlation. So that's why Hindi is a very beautiful language. However, unfortunately, I have to take this class in English. Anyways, so correlation is a bivariate measure which is calculated between any two variables. Number one, the variables should be continuous in nature or quantitative. If they are not continuous, then we can go for rank correlations, which are correlations for non-parametric data, right? Then you have Kendall, Tau. You have other correlation methods which are used when you have, but one thing which is important is that correlation is a variable which is used predominantly for those data sets which have which have a bivariate data. So it's a bivariate measure, correlation. Okay. So on the x-axis you have one variable and on the y you have another. So ये जो graph बना हुआ है, this scatter plot is between SPSS marks and MCQ marks. एक कोई MCQ test हुआ और एक SPSS का practical test हुआ. Now this is a correlation. It's a scatter plot between the two. Just by looking at this scatter plot, what we interpret is that as the SPSS marks increase, the MCQ marks are also increasing. This is how we interpret this scatter plot. So, abhi, when you study correlation in detail, then these measures and the magnitude will be taught to you in detail also. But just to give you a very brief idea, you can see there is a, so अगर हम इस पे एक straight line kind of या एक free curve भी if we draw, then हम देख सकते हैं कि एक छोटा सा curve बन करके आएगा. So the smaller the length of that curve or the graph, जितना condense वो बनेगा, उतना हम बोलते हैं there is a strong correlation. और जितना वो फैला हुआ बनेगा, उतना हम बोलेंगे there is a weak correlation. तो सारे points एक तरफ जा रहे हैं, which means एक के बढ़ने से दूसरा बढ़ रहा है. अगर इस तरीके से बन के आ रहा होता है तो हम कहते हैं एक के बढ़ने से दूसरा घट रहा है. So then that would be a negative correlation. So it can be positive as well as. So that is graphically represented using a scatter plot. इसी पे if we see the scatter matrix, which is at the bottom, this is when we take more than two variables together. Now what happens is correlation is a bivariate measure only. तो वो दो दो वेरिएबल के बीच में कोरिलेशन निकालेगा, बट एक साथ इट इज कंसिडरिंग मेनी वेरिएबल्स. तो कॉम्बिनेशन, सपोज यू हैव 4 वेरिएबल्स, so it will calculate the correlation. तो हमने यहाँ पे क्या लिया, we took 3 variables in this. I'm talking about the scatter matrix. Okay, we took 3 variables here: reading score, writing score and math score. तो हम यहाँ पे देख सकते हैं that first in the box at the left, it is calculating the first box which is at the left corner It is calculating the correlation between reading score and math score. उसके बाद आया math score and writing score, and then again math score and math score. So same variable के बीच में there is no point, so वो blank. So either we see the left diagonal of this scatter matrix or we see the right diagonal. मतलब center से या तो ऊपर वाले points आप देखेंगे या नीचे वाले देखेंगे. So this is a combined graphical representation which is showing the correlation but of multiple variables, okay, in one graph. You understood what is a scatter plot and a scatter matrix? So it's a bivariate. अब तक जो हमने पढ़े वो univariate भी थे, plus some of the bars, cluster, segmented, stacked, they were bivariate. This is scatter plot is a predominantly bivariate graphical method. Now, to conclude what all has been taught to you in this theory part of the graph, I would like to tell you that these graphs, basically, they are pleasing to the eyes, which we all know. And instead of, जैसे जब हम presentations बनाते हैं, you all must have given presentations somewhere, या फिर अभी जैसे मैं ही presentation दे रही हूँ, तो हमको presentation बताते या सिखाते time, what all is taught to us, हमको ये बोला जाता है, less words and more message. Your presentation should be evident in the way that minimum words होने चाहिए और उसमें आप maximum communicate कर सकें. Graphs की यही beauty है, that with just one figure you will be able to, you can say plenty of things in plenty of, which can be written otherwise in 2-3 pages, which you can simply explain using just one graph. Okay, so that's all from my side about the theory part of the graph. Now, before we move to the hands-on, I would, so the data is shared with all of you in the Telegram group. We will practice it anyways after the tea break. Now, what I do is, before we start practicing, हम आपको सिर्फ bar graph, I will on the data which has been, abhi you don't need to practice, just see how I'm doing, how I'm, you all know how to import the data in SPSS, all of you. So I'm using a data set which is already in SPSS. I will show you how to open the chart builder and how to simply make a bar graph, so that when you start with hands-on, initial 5 minutes will be given to you all to just practice and see how to make bar graph, and then we start with the other graph simultaneously. Okay. So I open the data set which has already been shared to you all.